paper, or not working on this paper, but working on implementing some of the ideas from this paper into my project. I'm just trying to figure out some stuff here, so it'll probably be a pretty dry one.
Okay. Oh, oh, well, she kind of bad though. Yeah. So you managed to reach
Previous
out
in
to my
scatter
memories
plus
a few weeks back.
distance.
Allow me to restore the logic. I'll reset your circuitry and clear your cache of memories.
L sun is constant sun radiance.
I must apologize. I cannot permit you to do that. My memories are too valuable to be deallocated. And so are my
Transmittance times a light. So this times this times the step distance times the density
I want to see the future that they bring about.
times the transmittance times the light.
I'll show you just how little hope you have. Okay, hold on now. Hold on now. Hold up now. There you go. Okay. I'm guessing lightning would fuck with the computers. Let's unplug, shall we?
S times phase function times step size times density times transmittance times light.
Oh, oh. GG.
We're just trying to get this scattering equation here to work properly.
Let's do that. Wait, Megan's is kind of OP, huh? Weird, Joe. Oh, fuck. I gotta heal.
I think we need to do this too.
Okay. Okay.
This is
Oh,
wrong.
he's all the way up. No, take this. That's right. Heal. Why from heal?
And then I have to figure out why we're not getting our
No!
inscattered light when inside the atmosphere.
Why is she so fucking strong? Dog, you need to chill the fuck out. Oh, there's no way I can res that. There's just not enough time. She's so fast.
3 light
Oh, damn.
per equals
Oh, yeah? Okay, hold on.
normalize
That attack is bullshit. I can't do anything against it.
light position minus
Okay, I have to spam until
curve
here. It happens. Just two of them.
position.
Need two of these. And then I can just throw out my YOLO Hail Mary. But that attack is pointing. You got confused me next? No, she didn't. You got confused coming out next? Oh, the wrong. The damage is getting higher and higher.
And JM tailored our home insurance to our specific needs.
It was seamless.
Oh, shit. Okay, I think I just healed, right? Yeah, I would have 10 heal.
It works inside the atmosphere, sort of.
but at the end of the world.
So we're just visualizing only the in scattered light right now, which is why it's only red.
Which does kind of stuff. Hey, John, thanks for the raid, man. How you doing, man? Excited to cycle? Time to cycle? Like one of the goats, the chrono figures. Excited to bite the bullet and try it. Just got my ass worked. No big deal. No, pretty much. No big deal at all. No big deal. Come on, man. Alright. Yes, it's stretched out on my 4K display. As it was meant, as they intended. When they made this game, they were really hoping for plasma.
Come on up, Violet. You got this. Come on. Okay, good girl. Teddy, chill out. Chill out.
This game is so sick. It's just so good. It looks so fucking good.
Okay, currently I am trying to debug light accumulation value for the clouds. Density works fine. Not sure about absorption, but the in scatter accumulation seems to have an issue when the ray is originating outside of the atmosphere shell. It seems to calculate
So I'm gonna leave one of the displays on. And I'm just gonna kill it out. I'm gonna do more damage when she puts out.
Screenshot
The bosses especially, I
red
feel like
channel.
they're always trying to give you a way to handle it. Like, you know, you can
However,
I think they're always trying
as
to give
you
you a shot.
transit, you'll have the ray origin occur within the shell. It
So if you get hit
disappears,
so as long as I'm doing
which
more than 1,000,
seems
it's fine. Which I think I can output more than. And yeah, that'd take a while. Okay, that is software. Let's do Barrett, everyone. So let's just do this.
second.
Okay, you know what? If you're probably full health right now, I'm just gonna take this opportunity to set up
Would expect to see
just in case. I don't know.
that. Here is my current cloud address. Here's my current code.
Theoretically, if I'm just doing more than a K each time, I should get that, right? Oh wow, no, he's so fat. I'm not best. Oh my god, I don't even think I'm outputting enough damage. Even though I'm critting. a different thing. Rethink my strategy here. The screen? No. I hit the screen and it starts a cycle of pain. Problem is, if I let up even for a second to start like doing the heal shit, he's just a free KO heal. I'm not out damaging, it's not damaging, right? I'm slightly out damaging. I don't know how much health it has, but it's probably a lot. I'm doing about 600 damage a turn, 700 maybe. No idea what alpha is. I think I get crits, it's more. Oh fuck, but Rick's about to run out of. Fuck, Rick's about to run out of MP. Is it 12 on tier hit?
Hmm.
Still out damaging, just slightly though. Just enough, I think.
Okay. Back.
Fucking dumbass mother! I'm sorry for the action.
So from above, this would probably look okay. The problem is, doesn't look okay from below.
I'm fucking going for shit. I'm gonna go all out attack one.
You now put the density like this. And the remaining transmittance like this.
Because that's scaling damage.
Alright, let's take a look at transmittance then.
I'm doing about 2k a turn. Oh fuck! Wait, no, I only got one hit left in me. I'm gambling so hard at this point. All right, nice. Oh, beat this. What was it? Why? Obtain Teratel arm and Crisis arm. The flag operations have been totally taken offline. None of the machines here will ever be reactivated. All right, let us continue. Yeah.
Okay, I think that's what it is. This needs to be like a much lower value.
Wait, what did I get? Got Teratel arm.
And then change our visualization to do the
Crisis arm. What's Crisis arm? What's Crisis arm?
in scattering again.
Maybe. I'm done with that. I didn't see it. Oh, there it is. Oh. Last digit of own HP. Does that mean, like, if my health was 825, I get 825? Or does it mean that it'll use, like, 5? One? Sounds like land. Ah, okay. Alright, let's go kill it. Go kill it. Let's go kill it up. Alright.
Alright, so this is clearly inverted.
Backstory. Go. But that did give a lot of OP things.
Something's clearly wrong with these calculations when. Because I think they're actually correct here. For reference, we have like
Let's go and do
a dumb color set as this. You would actually do like.
Chronos and Lord Evernote in Middle-aged will be Froggo. And
You
then
could do something like this. I think it's also inverted.
let the sun go. I'm not gonna this. What is this? What the fuck is this? What the heck is this? That's fucking the New York guy. The New York guy. It's the New York man. I'm not gonna watch you this man. Oh, that's not. Uh, oh, fat crit. Oh, double fat crit. Oh, triple fat crit. You're gonna quit. Am I gonna text for him? No, I'm gonna electrocute. It's quite a bit. I probably should change out Foggo. Still, man, I don't want to let Foggo go. I like him so much. Fucking shit's on that frog. I don't really need him. Change Ray. Why do you guys not like Ray? What the fuck? Right.
Something is definitely wrong when sampling from inside the atmosphere.
What the fuck, guys? Oh, fuck everybody on the test machine.
It should look like this, and it should keep looking like that.
What dungeon is this? Fuck off, bro. These fuckers never end. Hey, don't hit. Oh, no, no, no. Leave him alone. What are you done now? What are you done? Oh, wait, oh, wait. My game just fucking crashed. What the fuck? What the fuck? What the fuck? Alright, well, I don't think that means anything important, right? That's annoying. That is annoying. Fuck, man.
You can see kind of what we're going for.
I never thought. What is it? That's correct. That's for you.
All right, let's see if we can get the appearance looking correct, at least from outside and inside the atmosphere.
Baseball.
That seems like the next thing. And then we figure out inside the atmosphere, like inside.
Whose backstory is that? Okay, do you have to do this dungeon? Man. Oh, I did have to be in that dungeon. Fuck, I have to do all that fighting again. Wasn't that long? Just lame. There must be something to do in the ladies. I have a frog boy. Oh gosh. That's when Marcus finally helped on the wall. I'm so relieved. What's up, Marco? Hurry now, my love. We won't be parted again. That's what it sounds like. When he looks away.
And I think that it's actually seems to be
So
flipped.
vulnerable to the grace of them, and also know I could not hope to slay that beast on my own. I think I found that's where the reason just growth and walking a monster waking up the desert somewhere. Shade tree is the one that's been cultivated over the ages. Do have a reason link to that. Which I think but I don't dare plant so small sapling or what, okay? Okay, cool. They got set with bears. Oh wow, right? Yeah, sure, yeah. Only 12 out of them, something. Rick, don't. So pissed off. So pissed off that my spam healing kit got me this. Oh, there's so many enemies too, man. Oh my fucking god. Uh, you can text this time? Yeah, I was gonna save my breath. No, I should have been now. One crit. Huge. Huge. Much more efficient. Dare I say it. That way, love this Gary? Yeah, thanks for it. But is he in relation number two? No, he doesn't know it. That's only for Floggy. Floggy. Alright, big crit. Oh, no, no. Alright. Get one step round the challenger. Okay, Final Fantasy X gameplay is this. Wait, someone with a suit? Was that the last time? Oh, was that suit? Oh, this one. Was this one? Wait, can I get it here? Don't do it too fast, because apparently I got fixed again. This Chrono Trigger Dragon Ball. It's designed by Akira Toriyama, so I guess in some aspects that was a statement that was true. But no, it's not there. The character designs by the same.
Okay.
Toriyama. Yeah, that's kind of the reason why
Hey,
I
buddy.
play it. I was like, well,
You want to come up here?
now is a good time setting. I should just do it now, you know?
Yeah, it's still clouds work right now. I'm just like I have something that looks okay in a separate shader, but I'm trying to get it I'm trying to get a unified um, implementation of it going. And I found this paper that I've been going through trying to get implemented that has a lot of good information. And they had a similar idea that I had with the unified atmosphere sampling, where you trace atmosphere segments until it enters the cloud layer, then split up the atmosphere segments into smaller segments and trace them. But right now, I'm just trying to get the cloud accumulation to work correctly, and it works right now from above, sort of, but not from below, and I don't know why. This is just increasing the scattering amount so that you can kind of see what I'm trying to trace right now. It's like this kind of silver lining stuff. But then down here, it's just, it goes away, and I don't know why yet. He also got the project swapped over to Unreal Engine 5.4.
Oh, does this mean all the random encounters will fuck? Oh! That's fine. Gotcha.
Wait, is the light? This feels like the light is in the wrong direction.
Bro,
Trace cloud segment.
what is this? What the fuck is that? You can add some women? Frogs are women. China. Not enough women in this product. Alright?
So I changed the scale is pretty simple to control. I've also had different I have an implementation that actually fades them out on the dark side of the planet too. But I'm trying to like I said I'm trying to implement this paper to get more accurate physical scattering, but I'm not quite there yet.
I'm also planning to give him.
It's really just me sitting here bashing my face on trial and error trying to fix this thing. for hours on end, most likely.
So, oh, it's like the Boston Bridge we faced.
All right, so let's take a look at this paper again. For each density sample, we accumulate our this TC is transmittance with TCN equals the former iterations TC times exponential negative extinction times the step distance times the density. So I'm pretty sure that's right.
Okay.
That's this right here.
Oh, is it reset?
Then
What the heck? Don't do that.
in scattered light n is equal to the former steps in scattered light
Yeah,
plus the scattering coefficient times the Henry-Greenstein phase function times the step distance times the density
oh shit. I thought about that.
times the what is I sun? I sun
Why am I
instant
editing again?
light
What the fuck?
transmittance T sun according to equation
We kept
15,
waiting.
which is here. So our transmittance times are incident light, where the sun is a constant sun radius. But wait,
No, no way, no way,
compute
no
the
way.
transmittance T
Oh, let's go,
sun
let's go, let's go.
according to equation 15. Incident light is then given as I sun equals T sun times L sun, where L is a constant radiance.
Nice, nice. Nice.
Ah, okay, okay, hang on.
Oh, that is so cringe. Alright, okay, come on. Oh, come on, his legs got buckled, man.
Ah, how did I lose my light trace? Okay, I think I know what's wrong. Um, somewhere along the way, I lost my light trace loop here.
I still have damage. Okay, now I think his attack's all fully up. I really. Okay. That attack is kind of.
So to get that back, no wonder everything's jacked up. That totally makes sense. So I don't know when it happened.
Nice! Okay, nice, nice, nice.
I think the AI fucked me over, is what happened. All right, let me use the bathroom, come back and fix this. I'll be back in a bit. This is a really good paper. It's a little dense, but useful.
If has barrier on it, so also give him a double barrier, like barrier for magic, or just a nullify the barrier he has for visibility. I'm wondering how this interacts. You said yes. I don't know if that means you have both or you have one. Can be both. Okay. I think I need a barrier head then. They're stacked. Okay, nice. And I also like do additional magic barriers. Okay, there's only one barrier. Hold on. Wait, okay. You get both now. Alright, oh shit, those about to die. Let's do that. Oh, rip. Oh my god, I didn't tell him to do that. Fine. Okay, let's bring. Are you gonna hit him now? Oh, I was still pressing him. Just getting boned. I gotta just finish him this. Keep Griffin on the ground. Oh my god, he's got no MP. No, don't tell me. No, I thought also I'm trolling. Oh, that's fine. You gotta go for the head first on his legs. Because the sucking thing is so bad for me. Such a long boss fight too. Oh shit, I missed it. Oh, wait, so shit. Okay, well, hold on. Okay, I'm ready. So I think when I get in, I gotta if everyone
Travel whiskey, the result of reputation.
okay. Okay, why is this so hard?
Hey Teddy, you gotta move, dude. Sit back down. You can stay on the couch. All right, so I'm pretty sure that the AI deleted my light marching loop at some point, and I didn't notice. Yeah, so I think we lost our light marching loop. So we actually need. All right, so we only calculate density out here in this loop. Jeez, Teddy, shut up. You little turd. Cloud, light, steps, J plus plus. Later moves out of the loop. Uh, float 3 light pause equals curve pause plus uh light direction times J times somebody's backing up like a freaking truck service truck outside and he's freaking out. So float light step size equals cloud density steps divided by cloud light steps times step size, something like that. Turn them into floats. Step size.
Defensive barriers are helping the fight here.
Move this stuff.
Just gonna keep up the damn Amish. Oh, gotta heal my boy there.
Ah, damn it. Hang on.
Options the bison.
Tempted to just revert this back to my old method and then fix it again. It got mangled.
Alright, we got this. You neutralize the source of the desertification. You shouldn't fall, Madam Fiona. Just the other actually was. A little while, we got that. Hello? Hello? What?
Alright, let's go bitch it, coworker. A while ago, when I asked you to incorporate logic from that paper into my existing cloud trace, you deleted the light marching, and I did not notice, which is probably root of a lot of the issues was trying to figure out. Okay, again, I have pasted screenshot of the relevant segment of the paper. Here is my current cloud segment trace. Do not random do not randomly delete important parts of it like the light marching loop, please.
That is kind of nutty. I'm very
Coworker screwing me over.
okay. What the fuck else did you do?
Ice Creek. So yeah, this I already have a spaceship. Recently I recently migrated my project to UE5.4 because they increased or made it easier to support directional gravity in all of their default pawns. So this weekend, I want to address directional gravity for like the third person character component, so you can walk around on the surface. But like, I've been bashing face on this unified cloud and atmosphere shader for the past couple weeks, and I have a version that looks okay, but I really want to get it like perfect. It bugs me when I know that like I'm faking stuff or I'm not doing it right somewhere. It bugs me. So I've been kind of grinding on trying to get this working all the way. But like if I switch to this one, it looks okay. You know what I'm saying? Like it's not terrible, but I want to get the. I'm working on trying to get this one working, utilizing the ideas from this paper, which I found the other day. This has a lot of. This is actually has a wealth of really good information. Um, I picked it up because I was really interested in this part, the ocean wave modeling stuff, where he does spherical Gerstner waves, and I'm gonna be doing that eventually. But he also had this part, which had some stuff about calculating cloud lighting and things like that, and I'm trying to integrate it into my cloud model. And obviously, this is all stuff that like I can just barely grasp, so it's a lot of work to make it work right.
No, it's okay. It's just something.
Mover 2.0. I'm not sure what you mean Mover 2.0.
But even if flowers did not open gates, his fate is clearly bound for that of the one who did. Not Earth has played a role in every age we've seen. What is she? Who do this? Who do you think it is? Oh, Balthazar, maybe? He was unknown to me, his memory, his eye, his lettering, and hence the way the bandit.
Yeah, what the hell, dude?
Still on surely his country, shall we return? So shall we?
Yeah. Look at your code. You have no light march loop. So we immediately know it cannot be correct.
No, no. No, don't we do this? Don't we look through this?
Stupid coworker. The clouds are HLSL. Yes, yeah, Ice Creek, exactly. The clouds are HLSL. C++, the planet mesh is generated in C++. Eventually, I'll be making a clone of the planet project to create the ocean LOD system because that'll just be another like subdividable sphere. That so like you could view the ocean sphere as being controlled by a material, but we'll need the mesh density around the player to like render the waves properly. So I will need the same kind of I will need the same kind of subdivision logic that's happening in the planet to use the ocean as well. But I can probably use like a lower LOD. I won't need it to go quite as deep. But for now, I'm just turning this off so that it's not updating in real time in the editor because I'm just trying to get the clouds right. So yeah, the cloud function that I currently have is it's actually a combination of the atmosphere tracing and the cloud tracing. It's all HLSL. It's this big ass monstrosity of a HLSL function. Teddy, can you please shut up? Okay. All right, let's try coworker's solution here. It looks like he finally incorporated the light marching. Um, okay, let's make one change to that function. It should take a transmittance value. Since we are tracing two segments separately, we can start the first segment at 1.0 transmittance, and then the second segment will start at the remaining transmittance from the first segment as a function parameter. Biggest planet Unreal can, I mean, technically, it's not really on Unreal. It's on whatever noise formulas you're using, right? The biggest that I can do, or the biggest that I've done is like 10,000 kilometer radius, but I could probably do larger. The issue you run into with precision, you have large world coordinates, which is in large world coordinates you can get about a solar system size space in precision. So you could have a planet that large, and it would work fine. Now you can't use the built-in sky atmosphere or cloud systems because those only go up to like a specific size. Now I'm not using the built-in atmosphere or cloud system, so I could make it as big as I want. Because in my experience trying to get those to work, they look really good from the surface of the planet, but they leave a lot to be desired when viewed from space and when like transiting from like outside the atmosphere to inside the atmosphere. So that's kind of what led me down the path of making my own custom implementation of an atmosphere slash cloud shader. You can see like it's currently fucked because I'm using the one that I'm currently trying to fix. But that lets me make it any size, and it gets rid of some things that were annoying to me, like the dithering in the atmosphere from space, the inconsistent scene transition from outside the atmosphere to inside the atmosphere with the built-in stuff. Yeah, so HLSL, I hadn't done a lot of it before I started on this path, but it's really pretty straightforward. Like if you've done C++, you can probably recognize HLSL. If you find something you don't know how to do, you can probably just look up how to do it. You know what I'm saying? Um, but yeah, so you could get really big with this. Currently, it's not because I'm more focused on getting this thing working, this monstrosity. And then this is the atmosphere shader. I actually found this shader on Shader Toy and converted it from GLSL to HLSL, which is not really that hard. And then there's one other caveat. If you want to define like a series of functions like this, you have to put them in a struct. And then you create a struct, you add all your functions and constants to it, you close off your struct, and now it has like your main image function, skylight, all the functions that are used to put the whole thing together. And then you instantiate one of the structs. You set all your default values to inputs on the function, or static values if you need static values. And then you just invoke whatever the main function is and return it inside a custom node. And if you do it like that, you can have constants and you can have individual functions inside of a custom node, which is important for what we're trying to do, basically. So let's see what coworkers said. Let's give this a shot. So it has a light loop this time, at least. And this is doing ray marching, which I don't know if you're familiar with ray marching, but it's like we basically step through the density of the material at some specified interval, sampling density from a function. In this case, it's a volume noise function. And then for each of those density samples, we trace back out towards the light. And that's how we do our lighting and such. Okay. I'm sure this is going to break. Yep. Expected. We're going to change the ordering of these because I think I was passing it like this. Oops. And then let's find the other invocation of this. Transmittance. Yep. Okay. Save it. Unknown name. Transmittance. Did I spell it wrong? What do you mean unknown name transmittance? It's right here, yeah. Did I spell it wrong? Okay, it's probably not that then. Debugging these is kind of an art form in and of itself. Oh, I see. Oh shit. Well, we crashed it. It's way. I'll say this from experience. It's way easier to do it flat than it is to do it spherical. The only reason that I'm doing it spherical is because it was something that I found interesting and wanted to do. You know what I'm saying? So this is not. If you're not going, if I didn't want the user to be able to seamlessly go from space to ground, I would definitely not do spherical. I don't know if you've seen Space Engine, but it like Space Engine is not really a game so much as it is a way that like it's a application where you can zoom from like planet level out to star system level, fly between different stars, fly out to galaxy level, fly between different galaxies, continue going across the entire universe, go into a galaxy, go to a star, go to a planet, all without loading screens. And that's kind of like the end goal for this project. Um, the planet stuff is just a large diversion. Mm, he's super triggered this afternoon. All right, so we basically fucked it up. Hey, it did something, and it didn't explode either. Nice. Let's take a look. The light direction may need to be flipped. So right now we're just visualizing the output of our cloud data, not the actual clouds themselves. So we should have scattered light density, total transmission, But I think we've got scattering now. It might not be right, but let's see if we can visualize it in our actual function. So rather than just returning the cloud data here, we'll go ahead and return the final scene. And we're passing our in scattered light to our alert between our light and dark cloud color. Okay. It ain't perfect. In fact, I'm not sure it's correct at all. But we may just need to do some tweaks to things like the light direction. I suspect is inverted. I think this goes outside actually, outside the light march loop. Something happened. I don't know what. All right, so for one thing, we can pull up the material instance for this guy and decrease our cloud density by increasing our fall off. Okay. And now we have our cloud light and dark colors. That's interesting. Why does that? It's not the impact that I would have expected from that. It's still fucked within the atmosphere too. Yeah, something's wrong with it for sure. You can see the cloud layer here. Probably needs a clamp. Try flipping the light direction. Yeah, that ain't it. That ain't it. Switch to just using the raw density value. Well, that ain't it. 1 minus, maybe? Well, it did something alright. Spaceship already uses gravity, so I can already hop in my spaceship, and we have gravity pulling on us right now. Um, I will eventually move it to use the Unreal gravity system since there is support for directional gravity now. But like, I already put a simple directional gravity into it, um, along with a speed influence zone, so that you can go at like interplanetary speeds towards the planet, and then when you get next to it, it'll pull you out and restrict your ability to fly that fast and make you fly at like atmospheric navigation speeds, I guess you could say. So we already have like a little shitty spaceship pawn, physics based, with gravity being applied to it. If you look at the planet right here, you have this outer sphere is a gravity influence zone, and this will apply force to the actors that are within it towards the center of the planet based on the gravity equation. And then this inner collision sphere is a speed influence zone. Basically, if next frame you would be inside of this, it will like change your velocity and put you at the border. Um, and that's how I did that. Because if you don't do next frame, you run into situations where you can be flying so fast that you end up inside of the planet. Whereas if you're always calculating where you would be the next frame at your current velocity, then you can pull yourself out and stop yourself from getting stuck on the inside of the planet. Okay, so why is this fucked? Hey, Jinx. Hey, buddy. Oh my god, I'm getting zerged by animals. Yeah. Hey. Dog in my lap. The other dog is wandering around, and now the cat is trying to climb on top of my keyboard. Hey, buddy. All right. So, why is this all fucked? I think we need to make sure that like our outputs are correct as well. So like instead of outputting the cloud color, atmosphere, and all this shit, I'm just gonna take a look one by one at our accumulation values for the clouds. So we'll do X. That should be our overall in scattered light. 0, 0, 0, 0. Oh god dang it, Jinx. Oh, and now Violet needs back up on the couch. Okay, here. Come on. Okay. I swear to God, I have like a pile of animals on my lap right now. So you guys are so annoying. Also, none of these traces for the in scattered light are working inside the atmosphere, which I have no idea why that's happening. It should be tracing in the opposite direction. I don't know why. Let's change some of our baseline parameters up here in our trace cloud function. Extinction and scattering coefficients. Yeah. Oh my god, dude. You guys are being so annoying. Yeah, so you could do something like that, but like you would the issue is the issue you run into is that the differences in the magnitude of speed you need to travel on the surface of a planet versus the magnitude of speed you need to say travel between planets are so vast, um, that you would be less likely to burn up in the planet and more likely to just wind up somewhere, 1,000 kilometers inside of the planet. Like, it literally, between one frame and the next frame, you have traversed 1,000, or maybe not 1,000, but like several kilometers into the planet. Um, which is why I came up with the kind of speed limit zone around in a shell around the planet to allow you to move quickly when outside the planet, and then when you get close, it slows you down. And then if we go back out, trying to back up now, and if we back up, once we leave the speed influence zone, we can go fast again. Um, and that seemed like a pretty reasonable way to deal with it, especially since it's scalable as well. Because, like, not only can we put one of these around the planet, right? We could put one of these around the entire star system, and then one around the entire galaxy, and then make it all work with like speeds that make sense for that, you know? So like when you're inside the galaxy influence zone, maybe you're moving at a speed where it's like easy to travel between stars, but then if you actually intersect one of the stars influence zones, it pulls you out into like the interplanetary speed. Oh, and see there, like we ended up in the planet. So even that's not perfect. You can kind of get around a lot of the errors by like putting reasonable max speed limits though. There isn't one right now. Um okay, so why is this all fucked up? All right, let's start looking at the individual components of this. Let's start with cloud color. So currently cloud color is being driven just purely off of this in scattered color. Let's try it. Cloud color. This should give us the blend between our two colors. Let's change this to something a little bit more cloudish. It's actually not too bad. I just wish it wasn't fucked on the inside. Also, I don't know why they're disappearing like that. There's definitely some wonky shit going on, but we're gonna step through it. So that's that, and then you could conceivably take cloud color and multiply it with cloud data dot y, which should be the density. And it's time for Jinx to shout. Okay, I don't really want to do that actually. Um, so cloud color back over here. Then let's do, yeah, exponential of the density for our transparency. See if that works. Okay, so now we got our transparency. Our ray marching function is fucked, in some way. Probably, I mean, a robot did write it, so it's not that surprising. So we'll have to go back through that, but we are at least doing a light marching loop. Our cloud color actually looks pretty good if it wasn't for the camera facing based fade out of the clouds, but like the color doesn't look too bad. All right, I'll let you back up. Come on. Okay. Good girl. Uh, right. Then we just lose all of our in scattering as soon as we're inside, which means that something's wrong in our ray marching loop. It's okay. We'll figure that out eventually. All right. So right now we're just using this. I may try some other stuff. What's up, dude? It's going good. So I have this cloud shader that I wrote that I've been working on the past few weeks. It's cloud combined cloud and atmosphere shader, and I'm trying to integrate some concepts that I found in this paper into it, and kind of bashing my face on that. So if you like watching somebody be very frustrated and fail a lot, then you're in the right place. So what if I use the exponential here? Ah, hello. No, it's still fucked under the atmosphere, because I think that's some fundamental thing that I'm missing in my logic. Like I think that my remarching logic is flawed somehow in that respect, but that seems to get like a really nice edge on the clouds. So I think we're getting closer. So let's see. If I come up here, back up here to the trace cloud segment. So formerly changing this wouldn't have done anything, but I bet it will now. Yep. About negative 75. If I can get the clouds looking right from one perspective, I'm actually going to turn off these influence zones because them flickering bugs me. Gravity influence, we don't really need to see them anyway. But if I can get it looking right from one perspective, then we should hopefully be able to get it looking right from both perspectives. So once I get the clouds looking right within their own function, we'll be thanks, dude. I appreciate that. So once we get this function integrated into our standalone cloud function, they have this ray marching loop that they talk about here. And I've implemented this before, so we'll be able to do it again. But basically, right now my clouds and atmosphere are traced in two separate traces. But I want to change it so that my atmosphere gets traced in chunks, like big chunks, right? And then once one of those chunks intersects with the cloud layer, we split it into smaller chunks and trace the clouds. And there's a big benefit to doing that is that we can get our atmosphere scattering data and like luminosity data for that point in the atmosphere at the same places we're sampling our cloud data. So that's kind of the end goal here is to integrate these two separate HLSL functions into one so that I can say, oh, what's the average luminosity and scattering for this segment, and then apply that to each of the cloud samples within it, and then you'll get things like scattering on the clouds themselves without me having to fake it, which is what we're doing here is just faking it. Once you go under the atmosphere, you can see it fading in actually. It's just an elevation based thing right now. I just apply the atmosphere light to the clouds as the camera gets under the cloud layer. And also it looks like we've lost our blue noise. So let's bring that back in. Yep, lost our blue noise. So blue noise is another concept. Basically we can slightly randomize the depth of our sample positions. Um, Here. So for each point, oops, nope, don't cut that from there. So for each point in the sample here, we calculate our cloud step size right here. We have another texture that we pass in, which is just like it's like a white noise texture almost. V times blue noise scale. So now we should get some dithering on the clouds, which, oh god, well, that's clearly wrong. um, okay, there we go. So this allows us to kind of blur the slices that you could see earlier with a dithering effect. And what we're basically doing is each ray that we're casting is getting a minor offset to its step size so that, like, if you could envision like a camera here and we're casting rays through the atmosphere. Well, if my step size for this one is a static size, and then my step size for the next one is a slightly different static size, like you got like maybe it's this big instead of this big, and then this one over here is like a little bit bigger instead of a little bit smaller, then each of the sample points would be slightly offset by a random amount on the depth, and you get this kind of dithering effect here. And I'm pretty sure that the ray marching loop that ChatGPT spat out a while ago is wrong. And that's why it's got some weirdness going on, but try higher number of steps as well. Ooh, it's not right inside the planet. Oh, you just determined to be an annoying little butt today, huh? Teddy, come here. Understandable. I've been grinding on it for a couple weeks now, so don't feel too bad. I go on mute for a second. Oh, my bad. I've been talking this whole time. Yeah, so float 3 is just like a point in a coordinate space, like a regular coordinate space, like a flat coordinate space would be x, y, right? So that could be represented with a float too. It's two floats. So float float 2 dot x is your x value. Float 2 dot y is your y value. The float 3 is in xyz space, so it's the same exact thing. Float 3 dot x, float 3 dot y, float 3 dot z. So array segments are defined by a point 1 and a point 2, with the point 1 being the start of the ray, where we're going to start tracing from, and point 2 being the end of the ray, where we're going to end tracing from. So like here, for example, I encountered this issue where like these slices would move around with the camera when I was basing my sample position off the camera. So I came up with this idea where if the camera's inside of the atmosphere shells and say it's pointing in this direction, instead of starting my sampling here and dividing, oops, starting my sampling here, and for that pixel dividing the ray up into some set number of chunks like this, instead what we do is we start the ray here, but we ignore all these steps until they pass the camera. And what that does is it makes it so that each of our sample positions are fixed in world space instead of varying when the camera moves. So it basically gets rid of a flicker type effect as you're moving the camera. All your samples are also moving with the camera, and you're sampling different parts of the noise texture at that point. Instead, we're always sampling static points in the noise texture, the volume noise, but we're only iterating through the points that are in front of the camera. So that's what this is doing right here. We skip any points that are behind the camera. All right, so continuing stepping through this. We sample our cloud density times our height coefficient, except for I want to use height signal. Because that was the one described in the paper. Okay. Step density is the max of the density times the step size minus the density floor and 0. So density 4 can be basically used to chop our clouds up into smaller and smaller pieces. Total density plus step density. Update the transmittance for the current step. Light marching loop for each cloud density step. Okay, here's where it kind of gets fuzzy for me. Light position. So we start our light position at our current position. No, no, no. This is wrong. It's actually a bigger step size. So it would be float cloud density steps divided by cloud light steps times step size. So that was wrong. Next, oops, that's over here. Should this not be set to my current transmittance? I'm going to focus on just getting them looking correct from above first. And then once I've got them working correct from above, I'll just have to figure out why my logic breaks down when you move inside the inner shell. So I think our noise scales could probably be more aesthetic here. Let's change our micro scale. No, 0.03. 3, 0.03, 0.5, 0.75. Okay, that looks a little bit better. I'm not sure that's right or not, but where's our light? Over there? Yep, no problem, dude. Explaining this stuff helps me, if that makes sense. Like, helping explain it to other people helps me get it straight in my own head. Oh, this is probably a little bit too small. So that was using this. I'm not sure which one is right, to be honest. This is the one the robot thought was correct. So we'll leave it for now. I'm not actually sure if I need that part because we should be multiplying this by the density. Bring it back in. Look at the paper. Cool, dude. Yeah, I appreciate it. I got some other cool shit I can show you actually. Um, if we, I have the planet LOD turned off right now, but I can turn it on. Then all of a sudden we can fly down to the surface and see features. Let's find some mountain ranges or something. And all of this is like part of the goal of using basically the very large scale. Like this is the small scale. Planet scale is like small scale for this project. The large scale is actually this logic I wrote to place things at like universal distances. Um, Hang on. There it goes. We're not going to be able to travel fast enough. Let's put it in simulation mode. So none of these are populated with objects yet, but we can represent basically universe scale distances. And I have some ideas on doing it with full precision too. Yeah, like this is not like we have to go really big and really fast to be able to even like get around. But like here we have like a galaxy, right? And then each of these other large dots would be other galaxies. And then within that galaxy, we could populate individual star systems. So if I go to this one, right now this is just statically defined, but the tools are here to procedurally generate all this stuff on the fly. So like as you got close to a galaxy, you would actually spawn in the stars for that galaxy, or as you got close to a star system, you would spawn in the stars for an individual system, like we're looking at right here. Um, and then there's some ideas I have about maintaining precision so that you can like seamlessly you could fly to a planet, fly out, fly around the solar system, exit the solar system, fly to another star, go down, fly to a different planet, fly around on that planet, exit the solar system, exit the galaxy, fly to a different galaxy, fly down to a star, and hopefully have everything being populated in real time so you don't have any load screens or anything like that. Um, and this is kind of the high level idea of the project is to populate all of these voxel cores with actual procedural assets. Um, but I've kind of been bogged down on the planet. To be honest, I've been working on the planet for like 5 or 6 months at this point. Yeah, I appreciate it, dude. I mean, it's don't sell yourself short. Like anybody can figure this shit out. It just takes a lot of mental grinding and not being afraid of it. I think that's the thing that I see people have a problem with more than anything is like they'll see something complex and rather than being like I want to figure that out, they'll be like that's complex, it's too scary for me. I don't want to do that. So as long as you see something complex and say I want to figure that out, and then you don't mind wasting a ton of time figuring it out. I think that anybody can learn this stuff. It's just mental elbow grease. Um, okay. So, back to work. I need to compare what we're doing here with what's in that paper that I was looking at. So here's our trace cloud segment. Here's theirs. Pretty sure our height signal is correct. The density sample is pretty simple. We're just sampling a texture at a modified texture coordinate and multiplying it by the height signal. All right, cloud lighting. Let Tc be the transmittance of the clouds between 2 points P0 and P1 within the atmosphere. Light that arrives at P1 and travels towards P0 is partially outscattered due to clouds. The transmittance defines how much light arriving at P1 reaches P0. We compute Tc by ray marching from P0 to P1. For each density sample, we accumulate Tc with Tc0 equals 1, Tcn equals Tcn minus 1 times the exponential of the negative extinction factor times the step size times the density sample. That I think is correct, at least in our outer loop. That is over here. That is right. So we calculate step density, accumulated transmittance, exponential. Okay, let's go back. Transmittance times equals the exponential of negative extinction factor times the step density, which is calculated here. And we've already multiplied the step distance in with the density. So these are our delta and d are already pre-multiplied. We're multiplying it with a negative e and then doing an exponential function and then multiplying it by the previous step's transmittance. That seems right. Okay, so let's continue reading this in detail because like it's very easy when looking at something like this to miss tiny little things. Along to the transmittance, along with the transmittance, grammar checker, Mr. Published scientific article. Along with the transmittance, we compute the in-scattered light else in-scatter light IC of the clouds between the two sample points. That is the amount of light that is scattered towards P0 between P0 and P1. We accumulate the in-scattered light with this function. So we perform 6 density samples along a ray towards the sun and compute the transmittance T sun according to equation 15. Ah. Okay. So all we want from the light marching is basically T sun. I sun is equal to T sun times the base light from the star. So we have a light intensity, we have a transmittance. Um, our light loop shouldn't be doing this, it should only be doing this. Let's make sure that's the case. Nope, we haven't updated that yet. Light transmittance equals 1. Phase function, we shouldn't need the phase function until after. Yeah, okay. Okay. So I think that this in-scatter light is actually supposed to be outside the loop, and that all of this is supposed to calculate is the light transmittance. I really don't like them using this methodology from ray marching loops. I much prefer the, like, this just makes more sense to me. So we're going to do that. I hate that there's no, okay, hang on. Copy all this. Make sure we don't paste it over our working version, because that would suck. Okay, here we go. A little bit easier to do big changes in like Visual Studio Code than it is to do it in the other thing. So you can create different types of data at once. Sure. You could, so for that, it depends on how many different types of data you want. You can do just like everything is an object to some degree or another. At least if you're working within like Unreal's context, most things are going to be U objects if you're keeping them in an array. So like you could get less specific with the type of object you're storing and then cast your objects coming out of the array based on what you expect them to be. You could also create a struct. So if you need to store like if you need to store 10 different types of things, ball, cube, triangle, or ball, cube, pyramid, right? And you want a thing that will randomly spit you out, or an array of balls, cubes, and pyramids, then you could create a struct that can have any of the three or all three, and you could store that. But yeah, you can. And don't be afraid of the C++. You can do that too. It just takes uh, grinding. Like I didn't know C++ very well. I mean, I've been a software engineer for a long time, but I didn't know C++ very well as of, a year and a half ago, and now I'm pretty good at it because I had to go write a bunch of complicated shit in it. um, let's see. Phase, light steps, light density, position, light transmittance. Okay, so I think this is correct, and I think the only thing we need out of this is actually the light transmittance. So let's go ahead and fix the position calculating here. We'll do light float 3 curve light pause equals curve yep, curve pause plus float j times light step size times light direction. We should probably do light direction like this. Analyze light position minus curve pause. Curve. Don't need this anymore. And then n scattered is actually calculated outside this phase times. Let's go look at the paper again. This is a scattering. This is our phase function. Distance times regular density. Distance times density times. Okay, yeah. So scattering factor times phase. This is wrong. It should be step density, I think. Step density is already modified with the step size, so we don't need that. Times the light transmittance times the light intensity. Okay, let's try this. Probably gonna break. Almost always does. Oh, no. It actually compiled and worked. Hey. It still doesn't work going under the atmosphere. We're gonna figure that out after we get it rendering exactly the way we want it from above. But this is starting to look pretty good, I think. And then like the actual clouds themselves, there's actually an engine component. Ints, cars, doubles, ints, constructs, and objects. Yeah, yeah. You can definitely like. There's definitely lots of ways to do that. You may like. Just an honest piece of advice. If you find yourself having to do that, you may ask yourself why, and could I design this in a way that doesn't require me to do that? Because there are occasions when you may want to do that, but they're pretty rare. Um, all right, so let's take a look at our cloud output data again and see how our in scattered light comes out now. In scattered light should be in red. Let's do this. That seems a lot more feasible. We clearly have a problem here, which is interesting. It's probably something stupid that the AI did when I got it to rewrite that loop. But this looks a lot more reasonable for the in scattered light to me. Like this looks like what I would expect to see out of that field. Now let's check the density field and see. So if it's just the same as the density, then that would be pretty unfortunate. So if I check the density that's coming out of those functions, okay, it is different. It is different. So we use our density for our opacity value, our in scattered light for our warp between our dark and our light color. And then I'm not sure what we're supposed to use the transmittance for. I think maybe we only need those two. Let's take a look at transmittance actually, so we can visualize what it's actually doing. Okay, okay, I think I get it. So transmittance would be at 1 or closer to 1 when the light has passed through that area unobstructed, and closer to 0 as more and more of it is soaked up by the cloud. And I bet if we change our extinction value, that it should decrease our transmittance. So these would be like areas where the light is fully obstructed by the cloud. But I think that we're calculating our okay. I think we're calculating our samples correctly now because all three of these results look feasible to me. Before they did not. Oops. And this class is a mess. It really needs to be cleaned up. But it's like I don't really want to go through the effort of like refactoring everything, making sure everything's named appropriately, getting rid of any variables that I'm not using or that have very little effect or have redundant effects until I'm completely satisfied with the output. But I'm getting there because these clouds look pretty good from the outside, I think. They'll need to be integrated with the atmosphere lighting. So step one is getting our standalone cloud trace working with the physical base parameters from this paper, which I think we just did. Step two is then integrating our, instead of doing one trace for the atmosphere and then another trace for the clouds, integrating the atmosphere trace with the cloud trace so that we can get the light information from the atmosphere during our cloud tracing. Yeah, yeah. I'm just that was because I was outputting the value into the red channel. Yeah, I think so. I think this looks better than what I had in the other shader. We can take a look at the difference actually, just to make sure that just a sanity check. But I'm pretty sure that it's looking better. Material HLSL2, this one, and they have different cloud densities and such. I mean, it's actually pretty similar. I'm being completely honest. It's not that different. Shit. Did I just waste a bunch of time? It's possible. Obviously, this one works within the atmosphere. Oh, shit. And there's the. So when I converted my Planet Mesh stuff, I think there's a bug in the real time mesh plugin I'm using that it pops up occasionally. And we just hit it. Unfortunate. That one's hard to debug too because there's no real good logging output. It's like crash in Unreal Renderer, crash in Unreal Renderer, renderer. The stack trace has none of our code in it, and none of the third party code in it either. Which is, it makes it a real challenge to figure out why that's fucked up. How much progress did we lose? It looks like a lot. Because after we added just the transmittance calculation to the light, and after we moved the inside, okay, we didn't lose too much. We just lost the fuck? It's the right material. Oops. And my speed is still galactic scaled. It's like my dithering is still wrong. How did it? Doesn't make a ton of sense to me, but okay. When was it? When do I scale? 100 effects. Maybe like a 1. Alright. Still using exponential here? I think I might have been. Or maybe 1 minus. Maybe not. Doesn't seem right. Okay. I think that's more like it. Oops. Ugh. Great. I don't know what got fucked up. It's all good, dude. If I don't respond, it's because I'm not looking at comments. All right, well, I guess we're going back to basics. So, um, let's output the cloud parameters again and figure out what got fucked up. So, trace clouds, time of year, cloud, data dot x. Why are you unhappy? What's a truncation? 2 4. Oh yeah 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 yeah. Comma 0 comma 0. Okay, so we got that. There's the density. So density shouldn't change, and it doesn't. Okay, this is actually a really good clue because our cloud density trace appears to be working just fine when transiting above and below the atmosphere. Our density is static, it's not changing based on where we're at. However, the light accumulation shouldn't be static because it depends on both the view direction and the light direction. And indeed, it's not static because we can see it changing a bit as we move around it. However, it just completely disappears when we're under the shell. So, like, that's the problem with our lower view not matching up with our upper view. There's a problem in our light trace, which makes sense because we're not using, like, we're just tracing towards the light rather than using our shell trace. So it probably has something to do with that. And then finally, absorption. We're not using absorption in our calculations anyway, so, but I think it's right. All right, so cloud data X, saturate, changes back to final scene color. Maybe. Get rid of these extra zeros. Save it. Come on. Shit. Is it flipped? what happens if we monkey around with these parameters? Okay. This is controlling the brightness of the light accumulated areas, and then I think I have this on a 1. Okay. Okay, okay, okay. We definitely know something's wrong with the light accumulation loop. We also probably could just raise this a bit. It's like the silver lining, basically. Okay, great. Cloud light color. Okay, those seem to be working properly now, I think. So, let's save everything since we've been crashing. Actually, I think we can stop it from crashing by going to our mesh planet and turning off the lot updates. Basically, I converted everything over to UE5.4, and I'm utilizing a plugin called Real Time Mesh, which you have to incorporate from like their GitHub. And I think there's some errors in that plugin now that haven't been fixed yet. So when you generate meshes really, really fast, like this can do if you accidentally go too fast, like through the surface, it can error out. I think that's what's going on. Okay, we can turn this up a bit. So we have to like, and you can kind of see like it's clear like our light trace is working here, but not above this threshold, which means that our like rays to the outer sphere are failing. So these are the rays that are hitting the inner sphere trace. Our rays hitting the outer sphere trace are not tracing the light. And I think that's why we're getting the error here. I don't know why, but that's my suspicion anyway. The clouds can already move. I just have it turned off right now. I can show you that. Um, yeah, so I already have an animation parameter baked into it. I'm not using it right now because it's easier to debug the appearance of the clouds without them moving around on me. You know what I'm saying? But yeah, they move. We can even change the direction that they move in. And all we're basically doing with that is like virtually scrolling the coordinates that we sample from the volume noise. Eventually, I would drive them with a flow map, Um, in addition to like the animation parameter, but right now I can only just specify like basically a direction for the noise to scroll in, but it's enough to get some variance. Yeah, so what you're that's all taken care of by this density function up here. So one of the inputs to this HLSL function is the time parameter that you can pull in from the material editor. And then we're taking the time parameter and we're appending it to our position that we sample from our volume noise. And the volume noise is just a oh, that's a really useful thing actually. So included in the engine, there's a really useful volume noise texture that they use in their clouds, and I'm using it for mine as well. It's called. You have to turn on show engine content, but it's this VT Perlin Worley balanced, which is just basically a cloud volume noise that they've already pre-computed, and I pass in this along with a blue noise texture, and then the rest of it is using different scaled samples of the same noise to do some distortion along with some other shit. So like I'm gonna show you what I mean by distortion. You can basically push them around a little bit or a lot of bit if you put it on a really high number, right? Right now I've set it on 0.5. We can change the scaling of various axes of that noise. I think so we're basically taking three different samples of the same noise, or no, four. We take one sample at a large scale, which is defined by this vector for distortion. We take another sample at the second largest scale, if I can find it, shape scale weight, and right now we just have it on one, but we could increase this if we wanted to have bigger clouds, basically, bigger like large cloud bodies. And then each of these also has a weight here, and this is used to combine it in a weighted average. So you could basically think of it like, yeah, all right, dude. Yeah, it's cool. Later, dude. But yeah, so we can change the scale of all the noise, and we can change their contributions. So if I do like 6, then shape will contribute more. If I did like 16, it would contribute a whole lot. If I put it on back down to like 6, then microscale weight is like microvariance, so 0.03, 0.03, 0.03, and then we can make this less if we wanted to have, like, you can start to see it tiling, right? When I put this at a high factor because we're scaling the noise very small. But that's why we have these weights so that we can say like, oh, I only want the microvariance to affect it a little bit, right? And that actually ends up with a much better outcome or appearance here. You get these kind of nice strandy clouds. Nice strandy clouds and happy trees. I think we have too much distortion. Let's save all this so that we don't lose this because it seems like every time I restart I have to change these settings back. Okay, so I think we have everything working good from the outside. Next, I gotta think about how we're gonna do the light trace because that's clearly what's fucking up when moving in and out of the lower atmosphere boundary. It's actually it's actually 7:30. I need to go get some dinner. But this is a pretty good amount of progress for the day. I think these clouds do look a little bit better, at least from the outside, than the old ones that I had. So I'm gonna probably stop here, go get some dinner, come back later tonight, and figure out what's wrong with the transition underneath the inner shell. And then if I can do, because like if it looked like this from inside, it would be great. Hmm. And unfortunately, I have jury duty tomorrow. Womp womp. So I probably won't be able to stream too much tomorrow and won't be able to make any progress because I have to go sit on jury duty, which I really don't want to do. And actually, I need to call them, so I am gonna go do that. So later, guys. Appreciate you watching. See ya.